Turning now to our second panel, we are going to have a panel that is talking about balancing security and safety in aviation. Safety is critical to aviation, both to operators, to manufacturers, and to regulators, and to have the safest form of transportation globally with the ability to operate around the world. We must keep aviation secure in order to keep it safe. This session will define security by examining how to maintain safety amid security threats, and addressing the roles of spoofing, jamming, and security standards. Please remember that you can submit questions at any time during the session using the Q&A button on the bottom of Zoom. And please join me in welcoming Sam Masri, Safety and Cybersecurity Specialist and Avionics Certification Engineer at Honeywell. Sam will be moderating our next panel. Over to you, Sam.
Thank you, Rebecca. Hello, everyone. I'm Sam Masri with Honeywell Aerospace Technologies. I'll be moderating panel 2 today. Our panel features 3 esteemed experts from leading organizations, Airbus, Boeing, and CASRA. Before we dive in, let's go ahead and have each panelist introduce themselves. I'll begin with myself. I'm an ODA engineering unit member with Honeywell, also a TSO specialist focused on aircraft cockpit systems. Additionally, I serve as secretary for RTCA's Cybersecurity Committee, SC216. I hold a bachelor's degree in electronics engineering from George Mason University and an MBA from Johns Hopkins University. And now I'd like to invite Timo to introduce himself, followed by Lillian and Adam. Timo?
Yes, thanks, Sam. So my name is Timo Vance. I'm part of the aircraft security organization inside Airbus Commercial. I'm an expert on aircraft information security with 15 years of experience in this area. So my original background is in computer science. I hold a PhD regarding fault-tolerant distributed computing. And I'm very active also in different standardization bodies around the topic of aircraft security at ICAO, RTCA, EuroCAE, and also at AirInc level. Over to you, Lillian.
My name is Lillian Ashbaker. I am a product security engineer at the Boeing Company and Whisk Aero. I have 15 years of avionics development, background in mechanical, electrical engineering, as well as cybersecurity and systems engineering. In between all of that, I am also the talk organizer at the Aerospace Village as well. Over to you, Adam.
Hello, good day, everyone. Adam Troczynski representing Swiss-based research institute CASRA. I am actually from the aviation security, traditional aviation security domain with probably more than 15 years of experience, including managing position of head of security for an airline. So I'm currently in the as a head of consulting and services in aviation for CASRA, and really glad to be today on this panel. Thank you very much.
Great. Thank you. Thank you, everyone. Today's presentation will address balancing security and safety in aviation. We have 3 concise presentations. Dr. Timo Warren's presentation is on protecting aircraft safety from information security threats. Lillian will have a presentation on security assurance in aircraft development processes, and Adam will have a presentation on impact of security measures on safety. At the end of the 3 presentations, I'd like to invite your questions, and please type them in the Q&A box at the bottom. We plan to address your questions after the presentations as time permits. Let's go ahead and get started with Dr. Timo Warren. Timo?
Yes, thanks, Sam. So in this talk, I'd like to give a high-level overview on protecting aircraft safety from information security threats. Next slide, please. Let's first take a look at some fundamental definitions to get a better understanding regarding the interaction between safety and security. So ICAO Annex 19 defines safety as the state in which risks associated with aviation activities related to or in direct support of the operation of aircraft are reduced and controlled to an acceptable level. So we can see that this clearly is about management of safety risks. And safety risks are the combination of probability and severity of hazard consequences, which includes injuries of a person, aircraft damage, or structural failures, missing or inaccessible aircraft. On the other hand, information security can be considered as a composite property, composite of confidentiality, so the absence of unauthorized disclosure of information, integrity, so the absence of unauthorized modifications, and availability, so the readiness for correct service. So for security, we need to protect these properties against information security threats. So how do safety and security now interact? Well, the security threats may violate the security properties, and this may pose a safety hazard. So for ensuring an appropriate level of aviation safety, we also need to protect against some or against certain information security threats. Let's next take a look at the threat surface that we are having, in particular with a focus on aircraft security. Next slide, please. So this figure shows the overall threat landscape as an extract. So security threats arise wherever systems or their components interact, so at their interfaces. We have aircrafts have a multitude of interfaces with some differences depending on whether the aircraft is in production, in operation, or in maintenance. So during the production and maintenance phase, for example, different devices and tools are connected to the aircraft. For example, consider a maintenance laptop, which may be affected or which may be infected by malicious software like malware, and this malware theoretically may propagate to the aircraft during production or maintenance. Of course, as we heard in panel 1 already, supply chain is a huge topic. So we have a complex logistics with aircraft parts stored and distributed all over the world. So threats on these aircraft parts in the supply chain may interfere with the parts before they are installed in aircraft. During the operational phase, we have different internal and external interfaces that may serve as threat vectors. So internal interfaces in the cabin and cockpit area, for example, include USB plugs or maybe Wi-Fi networks that may be used to attack certain aircraft equipment. We have different external interfaces, in particular radio interfaces, for example, with satellite vehicles, or with terrestrial infrastructure, or with local airport infrastructure, again, like Wi-Fi networks or maybe cellular networks, for example, serving for communication, navigation, and surveillance purposes. So we have quite a threat surface here. And now the question, of course, is what do we have to do in front of the threat surface? Next slide, please. So let's take a look at the regulatory perspective. Aviation is a tightly regulated domain. And from a regulatory perspective, safety and security come together, or safety and information security come together under the term airworthiness security. So let's take a look at the regulatory requirements and how to comply with them. So I've chosen the European example here. So the European Union Aviation Safety Agency, EASA, has updated their certification specifications regarding security requirements. For example, for large aeroplanes, we now have CS 25-1319 with requirements to protect against intentional unauthorized electronic interactions that have safety consequences, so against certain variants of security threats. It also asks to identify, assess, and mitigate security risks, so asking for a risk-based approach. And finally, the requirements ask to maintain the security level over time. So this tells us what we have to do, and it also gives some hints on how we can comply. Notably, it references some acceptable means of compliance, so the AMC 20-42. So these AMC, so the acceptable means of compliance, in itself recognize industry standards coming from RTCA and EuroKE. So there's a set of documents coming from RTCA and EuroKE which define the process for airworthiness security and, for example, also some methods. For example, the next talk coming from Lillian will give some more details on some of the methods. So this example is related to Europe, so the European regulation, but of course other regions and other authorities have similar approaches. The FAA, for example, for the US, have a notice of proposed rulemaking where they have announced to update Title IV of the Code of Federal Regulations, which will introduce also 25/30/19 requirements along the same lines as EASA has did. So this shows us what to do and how to comply with the regulatory requirements. So what does it mean for single stakeholders like Airbus as a manufacturer? Next slide, please. So for Airbus, this means that we have to cover security, information security, across the complete life cycle of aircraft. So we have to consider security during the design and implementation phase, of course, also along with validation and verification activities, so security testing, pen testing activities, and similar. But also we have to cover the operation in service and the maintenance phases. So this means that we have to define security architectures, aircraft security architectures, along with system security measures that are sufficient to mitigate the identified risks. And of course, we are following fundamental security principles, best practices like defense in depth, for example, meaning that for relevant threat scenarios, we have to foresee multiple security barriers addressing these threat scenarios. We have to define aircraft security architectures that prevent bypasses of the security barriers that we have defined, and other principles as well. But of course, there are limits to what any stakeholder can do on his own. Notably, if we're talking about protections regarding external interfaces, so radio interfaces with the outside world between the aircraft and the ground, or between aircraft and satellite vehicles. So here we need to have standardization activities where the industry comes together to define protections that ensure interoperability. So of course, Airbus cannot on its own, or manufacturers cannot on their own define security protection for external interfaces. The ground needs to play along to ensure an interoperable solution. And of course, we are also targeting globally harmonized solution with clear allocation of responsibilities. So clearly allocating who needs to protect against what. There are many standardization activities ongoing regarding the topic. There are too many to list them all of here. I have made an extract. So for example, there are different ICAO panels working on the topic. For example, the Trust Framework panel, which works on a common profile for digital certificates. And we will have some information around this Trust Framework later on in the summit. We have the Communication panel working on future connectivity, including cryptographic protections. Or we have the Navigation System panel working on protections against certain variants of GNSS spoofing, which also is a very current topic, as we had on panel 1 already. Along with this, we have different RTCA EuroCAE committees working on the topic. We, of course, have the Aeronautical Systems Security Committee, which has developed the standards that I just mentioned before on airworthiness security process and methods. But we also have other committees like working on communication, like AT and IPS. It's a future communication standard, including the already mentioned cryptographic protections. We have committees, for example, on GNSS receivers or on radar altimeters, including requirements for increased resilience against RFI threats. And as I mentioned, there are many other bodies like ARINC, SAE, and so on and so forth, with also their share of activities. Maybe to conclude on this, all of these activities by individual stakeholders, but also by industry groups and standardization groups, are essential for ensuring an adequate protection of aviation safety and aircraft safety against security threats. Thanks. And then over to you, Lillian.
All right. Thank you very much, Timo. As Timo had discussed, we're going to talk a little bit more in depth about the security assurance aspects of how we do aircraft development and how we use a lot of these standards in order to drive system security into our development. Next slide, please. So when we talk about design assurance levels and security assurance levels, we want to have a good definition and understanding of what we're actually talking about with regards to our system. So on the safety side, we have the design assurance levels, which fall under different what are called DAL, functional DAL assignments that have a quantitative and qualitative definitions that are put around them from a lot of the different ACs and publications that are out there. And what this gives us, it gives us this probabilistic effects on our system for the safety. So when we look at this from the aspect of security, we need to know at what points we can affect the safety of the system and what the probabilities of those system failures are, so that we can adequately protect them from failing outside of these normal design parameters that we've put here. Next slide, please. All of these probabilities, as I stated, are quantitative and stochastic predictions for the functional DAL assignments. We don't have that on the side of security, because security is an event that just happens that we protect against. When a security attack lands or is able to break through on a system, it happens. There is no probability of that. So part of this is that we have design assurance objectives that we have to meet for the different security assurance levels of our system. This is very much in line with the way that DO 178, DO 254, 278 objectives are laid out as well, where there is some amount of objectives that are needed to be met through the different artifacts that we produce in the development of our system, right? So as the DAL and the SAL increases, the amount of requirements verification, validation, refutation testing on the side of security, and documentation that goes into this development. Next slide, please. And so when we take a look at DO 356, ED 203, what's really interesting is that it doesn't follow in the same probabilistic expectations as you have for DAL assignments. And in fact, it goes a little bit further and shows that you have to provide additional assurances for the different threat categories and conditions as they get worse in the system. What's really important to understand through all this is that we're not talking about individual systems themselves, but we're talking about a functional thread that runs through systems. Because at any point of the data traveling through a system, you can have effects on that data that will then disrupt the overall security of that function in the system, aircraft system. So what we want to do is we want to ensure that all points along the system are adequately protected, depending on the DAL level of the systems that we have, and also depending on what the threats are that we have. So there's kind of a multivariate problem that goes into determining what the threat condition is for the system and the risk condition is for the system. Now, one thing that's really important to note here, if you look at the chart there from DO 356, we have a catastrophic threat condition that requires two assurance levels, right? A SAL 3 and a SAL 2. So that means that you have to have two mitigation requirements in your system that have that are separate and independent from one another, that have the objective that meet these certain objectives for the SAL 3 and the SAL 2 levels, with all the artifacts to go along with that. And there's a qualitative definition of security assurance level right below there. So you have to have something with the strongest security assurance and an advanced security assurance that meets the different design objectives for the system. Next slide, please. So as a kind of a little vignette into our system here, this is a very simple system where we have three different pieces. And what we have are in green are examples of what might be safety requirements on our system. Some sort of monitor that enunciates failures, a check on validity of inputs in our system. In blue, I have a couple of, through this example, a couple of security requirements that come out. But what's really interesting about this is that a few of these requirements could either be safety requirements or security requirements. In the case of hashing memory spaces, on the safety side, we might do that in order to protect memory spaces from environmental effects, such as SEUs, flipping bits in memory, or other sort of errors that occur within computing devices. Or on the security side, we might do a memory hashing in order to protect the memory spaces from attackers manipulating memory spaces. So you have two different aspects of the same requirement that you look at from different lenses. On top of that, you can also have detrimental effects for the system safety or the security of the system. So in the case of the denial of service protection over on System C, if we put that requirement in place for the security of the system because we understood and found that there was some amount of manipulation of data that would cause the system to halt due to the amount of data sent, if we put in denial of service protections, we might actually impact the safety of the system by cutting off interfaces and preventing data from flowing through. So there's a trade-off in the system design that goes between the system designers, the safety FHA analysis, and also the system security analysis that really is in concert and conversation with one another throughout the development processes. All right, and I believe that's it for me. So we'll go over to Adam, who will talk about more on the future work that's going on.
Thank you, Lillian. And again, good day to everybody. I will cover in this presentation the topic already mentioned by Gian Andrea in his video, which is the EASA project impact of security measures on safety. If we can go to the next slide, please. So in general, the project originates from the notion that application of aviation security measures may have an impact on the overall level of safety in civil aviation. And this is even more evident after presentations from Timo and Lillian. The objectives of the project are to identify interdependencies between safety and security, assess impact of security measures on safety, analyze impact of security threats on certification standards in broad range of certifications across the aviation domain, as well as develop recommendations to support integrated decision making in the field of safety and security. So the timeline of the project is spread across a few years. I will just focus on one element that is called task 3 of the project. And if we can go to the next slide to be more specific, it will be about the subtask, which is impact of security threats on aircraft design, standard specifications, and best practices. So what we are doing here is basically to investigate elements that Timo and Lillian described, but I think I need to mention here at the beginning, we're not only looking into the information security threats, we're looking as well into the physical threats. So what you see on the left side of the slide is our research methodology, and it includes 3 elements. So first is study of methodologies on risk assessments. And here we have 3 domains: safety, security, and information security. They use a range of risk assessment models. Some are more popular in a specific domain, some are more used across different domains. So we had a look into all of them. The second element that we are looking into is physical and information security threats. So the catalog of threats, which was initially designed in the previous parts of the project, but we are putting it into the list of threat scenarios, which then we reconcile with preventive security measures. Those preventive security measures are based on EU framework, EU regulation, and pretty much anchored in the documents 300/2008 and implementing regulation 2015/1998. Last but not least, we analyze current aircraft design specifications, and this is mostly referred as a EASA CS25 document, and that was the foundation for our documentation review. As a next step, we, as a project team, needed to take a decision what kind of analysis we can conduct moving further. And so we decided that probably the most suitable will be the bow tie analysis model, which is widely known in aviation safety. perhaps not so popular or widely used in traditional aviation security, but it seemed to be working for the research work we conducted within that project task. So we needed to slightly adapt a typical bow tie model that is used in safety, because we're talking here about security, but actually both elements of security, one being physical security and the other one being information security. So on the left-hand side, there are threat scenarios we developed based on the input. Then this is run through the barriers, which in this case are preventive security measures. And then moving to the right side, we have mitigations. And here I also need to take a note of the fact that in terms of mitigations, we focus on aircraft design standards. So this mitigations overview doesn't include elements like procedures or training for cockpit or cabin crew. So moving on with the project, we also launched a series of surveys and stakeholders outreach in terms of gaining insight and consultation that was done through workshops. And if we go to the next slide, you will see main takeaways from the different stakeholders. In general, there was a high recognition of risks embedded in the aviation sector, and that goes across 3 domains. So again, same as Lillian and Timo mentioned, we see that interdependence, we see that common scope that safety, security, and information security is looking into. Although we're aware, we acknowledge that certain differences remain when it comes to terminology or even the details of for example, risk assessment that is being conducted within the domains. What is interesting, we actually, when we reach out to stakeholders, we noted that the gaps identified in the system were less of concern in 2 cases. So either when the threats are known or when there is a robust, well-developed and sort of a long-standing catalog of preventive security measures. And this is where, for example, for a person like me, people with the typical physical security background, this is interesting compared to information security. There were great speeches in the beginning of this summit where the concern was raised about the unknown unknowns or known unknowns. So this actually seems to trigger the assessment where stakeholders say we've seen some major gaps. In terms of mitigations, it appeared quite evident that the aircraft in itself shall not be considered the first line of defense. And again, please bear in mind that we're looking at both physical and information security threats. So could be that this philosophy is anchored in physical security prevention and the way the security measures are understood. But from what we see from the previous presentation, it could be also extrapolate to information security domain. And also the understanding that the primary implementation should be on the ground. I put it in like quote, as it's probably difficult to apply in the information security domain. But I think the way it could be explained is that, and supply chain was mentioned today as well, that we apply those security measures, let's say, as far as we can from the aircraft itself. So the perimeter defense starts quite early. What is also interesting from our stakeholders' feedback is, and Lillian referred to that as well, is that some aircraft design requirements, they may have not been even developed or sort of codified with the security mindset in mind. There was maybe no security reason, but they can help. They can actually leverage when it comes to the mitigation. So So some mitigations developed for safety can actually help in handling the situation caused by a certain threat scenario in certain conditions. However, it could be also the other way around, where safety and security has a bit of a different vector. So moving on to the last slide and to try to translate it to an actual example from our research work. What you see here is just an arbitrarily selected one of the threat scenarios, which refers to other threat items in the cabin. This threat scenario is analyzed through the angle of existing preventive security measures. So again, this is based on EU regulatory framework. Next step is the identification of potential gaps, which then is looked at through the angle of mitigations that are related to aircraft design requirements. So what is interesting about it is we're getting that link between three domains. If we would limit ourselves only to physical security, we could this analysis helps to reinforce the link between safety and security. If we add here information security, we get even more interdependencies and links between three domains. And then at the end, we attempt to come up with some recommendations for future and for further developments, which is especially challenging when you look into the design process and how much time it takes, and actually what the threat landscape could be when the aircraft enters into the service. So this is a very concise overview of the project. I hope it's somehow helpful. And with that in mind, I would stop here and invite my esteemed colleagues from the panel to join by turning on the cameras and moving on to the discussion and Q&A. Thank you very much for your attention.
Thank you, Adam. Thank you, everybody. I was listening to your presentations, very insightful. Timo, in some regions in the world, like you've heard, or we've been talking about, aviation is significantly impacted by GPS, GNSS jamming and spoofing. You mentioned that ICAO, RTCA, EUROCAE have some ongoing activities to define mitigations. Can you please provide details, elaborate on these mitigation development activities?
Yeah, let's maybe first focus on the more technical activities. So here the ICAO navigation system panel is working on including some authentication capabilities in the standards and recommended practices, so into the Annex 10. And notably, this covers the authentication of SBUS messages, as well as the authentication of some navigation messages from some core constellations. At RTCA EUROCAE level, the activities is focused around the upcoming MOP standard, so minimum operational performance standards for future GNSS receivers, so the DFMC SBUS receivers. And these MOPs will include additional requirements and test procedures to be more resilient against jamming and spoofing threats. So roughly speaking, the idea is to avoid outputting erroneous information under certain spoofing threats, also to detect radio frequency interference and to return to nominal operation after the receiver has left an RFI zone. So these are the main technical activities currently ongoing. But of course, there are many other activities, for example, to provide guidance regarding risk management of this particular topic, or to share, to collaborate and share on the evolution of the threat, so to share information to make sure that all parties are properly prepared for managing this risk.
Great, thank you. Lillian, do you have any insight as far as like activities or potential mitigations being developed in the industry?
Yeah, there are a bunch of different mitigations that are being looked at right now. And part of that is looking at the system as it's being developed, right? Because we take that into consideration as one of the threats to the system and make decisions on our system architectures based upon that. This is something that's been going on, how we develop some of the software pieces, how we develop some of the interconnections between a lot of those pieces as well.
Great, thank you. Adam, do you have any insight in your project on this topic?
I would need to honestly follow up with the members of the project team.
No problem. Appreciate it. So, Lillian, in the risk-based approach to security system analysis, how do you incorporate emerging and future threats into your risk model? How do you adapt your risk model to account for emerging threats?
Yeah, so one of the big ways that we look at that is to identify different risk areas based on, for instance, NIST framework risk profiles. And we take that into consideration as far as how different threats in the future might fit into those different profiles in order to mitigate those threats downstream in our systems.
Great, thanks. Timo and Adam, do you have any input on that?
So for sure, let's say also regarding the maintaining the security level over time needs to involve some form of threat intelligence, right? I mean, we need to be aware of how the threat landscape evolves and may need to update our risk considerations even throughout the lifetime of the aircraft.
Yeah. And especially when we look back towards aircraft that have been in service already certified, we typically want to go back and revisit how those different threats would impact all those different airframes and the systems architectures therein as well.
I could probably only add that we've seen that the same applies for physical security. So one thing is a typical risk model, but the entries you take, so the inputs you take, you actually have to just survey it all the time because there might be elements that you didn't need account for before. So I would say as much as information security is different, it's similar to physical security in a way that the world gets more and more connected, and it's sometimes it's actually bigger challenge to try to understand the information rather than actually get the information. The information is accessible. The challenge is what you can do actually to make it into something you can work with moving forward and which can actually feed your risk assessment.
Great, great. Timo, you also mentioned that airworthiness security follows a risk-based approach, asking to identify, assess, and mitigate security risk. Can you please elaborate on how Airbus performs these activities?
Airbus applies a specific risk assessment method. This risk assessment method is part of the industry standards that we discussed, so it's recognized as an acceptable means of compliance. And this particular method is based on assessing the effectiveness of security measures. So basically, we identify threat scenarios that may affect the assets of interest. We determine the impact of these threat scenarios, for example, based on safety assessments that are available for the systems and functions. And then we consider which security measures are in place to protect us and how effective they are. And the combination of the effectiveness of the security measures as well as the impact gives us a risk level that then drives further considerations to see whether we need additional measures for additional protection or whether we have reached an acceptable level.
Thank you, Timo. Lillian, is there a difference between a Boeing approach and Airbus approach to this?
No, we follow the same standards since that is the acceptable means of compliance. Same with the way that we're developing on Wisk as well, where we have a really unique system where it's not a large aircraft. We have a much smaller aircraft that we're working on, And so we have to really focus in on interactions between systems on board since we're trying to drive down system size overall. One of the other aspects of that is also domain segregation, right? There's definitions in ARINC 811 on different domains, and we want to try to keep all these different domains segregated and at least try to focus in on how data is flowing between all these different areas.
Okay, sounds good. And Lillian, since safety risk analysis is based on probability of failure, I want to touch with you on how is security risk scored and rated based on threats to the system?
Yeah, so one of the big pieces in there, as I touched upon in my presentation, is the effects onto the functions themselves, right? So as you start to look at the functions and the criticality of the data, as you get a smaller system, you have more points in which you can induce effects onto that data, and so that will also drive up the security risk score to the system. So there's a lot of management that has to occur on that security risk for the system, and then to adequately go through and pick points in which you want to go through and um, protect against those risks.
And Timo, is it the same system you use for scoring at Airbus, or do you have a different system?
So I guess you're referring to how the risks are determined. It's related to what I said before. We have this method around effectiveness. So we do not assess the security risk in terms of probabilities, but in terms of which security measures are in place and how effective they are. So that's maybe some difference with respect to safety processes. So the safety processes are, of course, very oriented towards probabilities, while we more focus on this effectiveness approach.
Sounds good. Adam, before we jump into the board for other questions that are posed by the audience, I'd like to ask you, how can stakeholders get updates on the progress of the project you described in your presentation?
Thank you, Sam. So as Gian Andrea displayed, there is a project website, and I am happy to post a link for those that maybe didn't want to scan the QR code or didn't have time to do it. And there's also a generic email made for the entire project group that is available on the project website. We also post on the website information about upcoming webinars. So that would be the main free ways if anyone would like to follow or maybe would like to provide some interesting input. The project runs till the end of sort of first going into second quarter of 2025. This element that was discussed today is with the, I would say, shortest deadline. So that would be my answer. Thank you.
Thank you, Adam. Now I'd like to jump into the Q&A questions that are provided to us by our audience. The first question came in from Mark Perini. Hi, Mark. He talks about the FAA authority to grant qualified individuals DER authorization. He mentions a few of the topics that DER cover, and cybersecurity is not currently one of them. And his question is, since cybersecurity cuts across multiple aircraft system domains, and since it typically starts with an aircraft level risk assessment, should the FAA add cybersecurity as DER delegation? I can tell you that this is, of course, it's a topic that the FAA has to address, but we have internally started preparing for such an event where our specialists do take a look at cybersecurity work and approval. And so it's definitely work in progress. The FAA is definitely interested in this. But like I said, I'm not really the FAA has to answer that question. Anybody has insight on this subject from the panel? Okay, so we'll go ahead and move on to the next question. It came in, it says, how is the issue of the inability of retrospective application of ED 202, this is DO 326, on system developed prior to ED 202 release, noting that there will be many legacy items on the aircraft that may not have
Sam, I'm sorry to interrupt, but I think we have to wrap up because I think the next panel session will come very soon.
Oh, okay. Okay.
Yes, I'm very sorry.
No, that's okay. So we'll try to address your questions offline. The remaining questions. Thank you very much to our panel, and we'll go ahead and conclude our presentation. Thank you.
Thank you. So thanks to all our panelists. So Sam Masri from Honeywell and the long-standing SC216 secretary, Timo Warren from Airbus, Lian Bakker from WISC, Adam Trocinski for CASRA, and the recording of this session will be available shortly in the event lobby as well as on YouTube. So feel free to revisit the discussion or share them with your colleagues. For those interested in receiving a copy of today's presentation slides, please email membership@rtca.org and we'll make sure to get them to you. Also, don't forget to check out our pre-recorded on-demand session on a range of related topics